Yeah. Okay. So, welcome to difference equation class. Okay. Today's class is really mathematics, so I hope you can bear with me. Okay. But uh, as I told you last time, difference equation really changed my life. Okay. So, and this is really a very important lesson that you can use in anything in your life. Okay, you can model anything in your life using differential and difference equation. Okay, so with that, I want to come back to our first slide. Our first slide. Okay, discrete dynamical system. Can you see my screen? You remember this one?
Yes, yes, we can see yours.
Okay. Do you remember this saving account? Okay, so I'm talking about this okay, modeling of discrete time, and then if we have this amount of money and the bank pay 10% interest, right? And then we talk about how we model, okay, first time of difference equation. I hope you remember this. And then we, at that time, we try to uh, do it more general using the same substitution. Okay, you see we are given the A0 and we know that A1 is equal to A0 time plus certain interest here, right? Say 10%, and then multiply by the principal. Okay, so this is the principal, this is the interest, right? So, and then you continue the algebra, and then you will get this result. No? AK equal to 1.1 exponent of k plus 1 times A0. Okay, so this is the derivation. So you notice here is k plus 1, and this is also k plus 1. Yeah? So it means if it is 4, this is also exponent 4. And we can generalize this. Instead of 10%, we can put it as I. And then the solution is this one, right? So if you look at this, if you have this kind of affine difference equation, okay, and you have the first number, so this is the recursive formula, right? Then you can find the solution, the general solution is something like this. Okay? This is just to refresh your memory. Okay, with that, let's go to the real topic today. Okay, so you go to Lentera, second order linear dynamical system or higher order. Can you see?
Pardon, sir. Second order.
The higher order linear
Okay.
system or second order dynamical system. I don't know what did I put there in Lentera. Oh, higher order. Yeah?
Okay,
Higher
higher
order
order.
difference equation. Okay. Okay. So let's start with the problem that Miss Indri has discussed with you half of the first semester. Okay, but now I will show in the mixing problem, right? So I will show in difference equation instead of differential equation. Okay, so in this lesson you will learn about how to compute a higher order. Okay, not the first order, is second order, third order, and so on. Okay, and in this slide I will discuss only second order. Okay, and we will go more detail later. I got multiple root and then non-homogeneous and then first order transformation and so on. Okay, so this is the example that we are talking. So this is just example that there is a river. Okay, the river will flow to the lake. Okay? There is a water body or river that will flow to the lake. Okay? So unfortunately, the river has been polluted. A lot of factories stay along the river. So all the water in Lake B come from River A. Okay? Now each year, certain percentage of water replaced in River A and Lake B, okay, respectively approximately about 38% and 13%. So 38% is in the river and then 13% is Lake B. Okay? That means every year, right, water is replaced, right, because going out. Okay? So that means the pollution is also replaced by the same amount. Okay? Now, the size of Lake B is 3 times of River A. That means the concentration of the pollution is also 3 times. Yeah? So now this year, year 0, the government make law to stop pollution in the river. So the question is, how long would it take the pollution level in the river and the lake to be reduced by only 10% of its present level? So before we go to the detail, do you understand the problem? Can you explain the problem? Livy, what do you get from this problem?
The first one. We know the
What do you know? There are
the,
river and lake.
the
Okay.
the rate. Yeah.
Okay. So the river going out of the lake or the river coming into the lake?
The lake come to the river.
The river coming to the lake.
The river coming to the lake. Okay. So then where the pollution come from?
The river.
Okay, the river. Okay. So and then the year 0 is today, meaning the government stopped to make the law to stop the pollution. Okay. No more pollution immediately in the river. Okay. And then the question is the time. How long to make the pollution level reduce 10%? Only 10%. Okay. So how are you going to solve this problem? Right. So to model this, okay, first you say we put a variable. Yeah? Number one, in solving any mathematical problem, you solve it by naming the variable. Okay, so let's define A is the total amount of pollution in river A, right? And then B is the total amount of pollution in lake B. Yeah? The year is N, so we just put N here. And what we know, this is what we know, right? B0 is equal to 3 of A0. Yeah? At this point, the initial pollution level is 3 times. And then from what we know, we also know that 38% of the pollution in river A is removed each year, yeah? Going out. Either maybe evaporation or going back to the river. Yeah? So in this case, we said, look, 1 minus 38% is 62, right? Yeah. So 1 minus 38% is 0.62. Okay. Can you get this why we put this equation, right? And then we know also that each year 13% of the pollution in Lake B is removed, yeah, maybe going out of the lake, okay, but because the river coming into the lake, right? So that means we have additional pollution from the river to the lake, yeah, which is also 38% here. Okay, so the amount of pollution next year in Lake B is actually 1 minus 13% out, right? So that is 0.87. And then plus the air pollution, the water pollution from the river, yeah, coming here. Okay. So how do you solve this? Now you have two equations. How do you solve this? How do you solve this?
Hmm.
Idea? Just the idea only. What do you think? If you now given the problem, right? Now we put into equation already. Now, how are you going to solve this? What we want to solve? What we want to solve is n, right?
Yes.
Hmm. So
We
how?
use second order derivative.
Huh? There is no derivative here, okay?
Oh, isn't just like what Miss Indri taught us last half of the semester?
Oh, how?
Like, isn't it similar?
Yeah, I think actually similar, okay? So one way to solve this is actually easy, okay? You solve it one by one, okay? You solve it one by one. So
Hmm.
why we can solve it one by one? Because this one is does not contain B in here, right? Right?
Yes.
Here only you contain A. Yeah, the B contain A, but A does not contain B. So in that case, we solve A first. Okay. So we solve A first equation, and then substitute that answer to the second equation. Okay, and then solve the second equation. So you want to try or you want to see the solution directly?
See the solution. We can try later
Okay,
on
you
another.
can try later. You did not do your assignment, you know. I give reminder already.
Yeah, I just found out. Yeah, I
Okay.
received your email. It got extended, right?
Yeah, yeah. Actually, should be
Okay.
2 weeks ago, apparently. Okay, so
I'll check it out. I haven't checked the. I didn't know that there was assignment.
yeah, okay. So anyway, today I will give you assignment on this, but very simple one. So additional.
Okay.
So this is what you are doing. First is this is the first equation, right? And then the solution of this is this one. My question. How do you know? How do you know the solution of this equation is this one? Huh? Remember the uh, first order earlier, the bank saving,
Mm.
exactly the same, right? You remember I showed a while ago. Right, this one. Okay. The way I wrote is different, but it's exactly the same. Can you see that? Right. So the solution of basically the first order difference equation, right, is this one. Yeah. So we already know that. So a exponent to n of y0. Okay. So with that, we can solve this equation. Okay. So second order. Come back here. right? So we already know this, okay? This is just similar to earlier because this is just first order, right? Okay, and this is the solution. So now if you want to ask how long it will take the pollution in the river A to equal to 10% of the present value, right? So that means AK is equal to 10% of A0, right? So then you put it here, AK is 0.1 of A0, okay? And then you know this equation. So if you have a exponent like this, what you will do, you log, yeah? You take the log, right? So you take the log of both sides, and A0 is on the right and on the left, so we can remove, right? Right? So, and then you have ln of 0.1 equal K, K is going down, right? Of ln 0.62, oh, K is equal 5. That means 5 years, right? So the river, if today we stop the air, the water pollution along the river, okay, the river will become 10% of the current level after 5 years. Okay, that's the meaning. So, and then we put it into the second equation. Yeah? So we put it into the second equation. Before that, we can solve the second equation, right? And this is the particular solution of it. Yeah? Again, the same thing. Okay, and we substitute the B0, which is equal to 3 of A0. This is the size, right? So then this is just simply algebra. Yeah? So you just put it in, right? And then put back the value here, okay? But what happened is if you want to solve this, okay, this is very complicated. You cannot use log, right? So what I'm doing is I'm using a solver in Excel. Okay, so I use solver in Excel, and this is the result. Yeah? 28.85 year. That means yes, the river will become only 10% of the current pollution level in 5 years, but in the lake, because it accumulates also from the river, okay, it will take 28 years, yeah, for the lake to become unpolluted as the river A. Okay, so this is how the mixing problem. Yeah, so you see, even if we reduce the current pollution level now, okay, it will take 28 years to clean up the lake. Okay, so all of this is basically same as second order. Yeah. So another way to solve that problem is to put it together. You see this equation a while ago, right? This is A and this is B that depends on A. What you will do is you just put, this is AN and then 0.62 of A n minus 1, right? And then you put it inside here, yeah? So then you will have two equation become one. Yeah? Okay, so now if you have two equations become one, okay, this is what you will get, right? So an plus 1 equal to a here is parameter constant, an plus 1 plus b times an. Okay, this is second order equation with two constant a and b. Okay, so how to solve this equation? Easy. Look, Yeah, if you have a equation like this, what you will do is you put this as x squared. Okay, a is remain a. Okay, this an plus 1 is become x, and then b remain b. So this an you just remove. Is this clear or not? That's the trick to solve. Okay, so if you, how about if you have a third order? Okay, the same thing. Yeah. So an you don't care. Okay, so you just put all the parameter, the constant like this. Yeah, the order. Okay, a plus 2 that become the square. Yeah? A plus 1 that become x. Yeah? An itself is x exponent 0. That means 1. Okay. So how to solve that one? So you solve this quadratic equation, okay, and then you will have two root, right? Usually, because this is quadratic. So let's name the root as r and s. Okay, let's assume for the moment that r is not equal to s. Okay, then the general solution of this second order linear dynamical system is this one in yellow. Okay, and then to find the particular solution, you need to give two numbers, which is A0 and A1. Yeah? If you have first order, you only need one initial value, which is A0, right? If you have second order, you need two initial value, which is A0 and A1. So if you know A0 and A1, right? And you know also R and S. What is this R and S? This is the root of this quadratic equation. Okay. Then you can find C1 and C2. Okay, that's it. So, if you have any question first, before I continue. Any doubt?
I don't quite grasp
Yes.
the,
Okay, which part?
if it were, because it's here in the slide, it's like alphabets, right? If we were to imply this
Okay, okay,
equation to
okay.
the previous problem, how would we do it?
Okay, so in the previous problem, you need to solve this one. These two equation together. These two equation you put here, right? So this is n plus 1, right? This one is n plus 1, correct? So, but this in here is n, right? So if you want to put it n, what you will do?
Make it -1.
Yes, so this one become an, that means 0.62 minus 1.
Yeah.
So then you can put that Bn plus 1 equal to 0.87 Bn plus 0.38 multiplied by 0.62 of An minus 1. And then you said, look, I still have An minus 1. Yes. So, and then you can substitute that An minus 1 into something else. Yeah. Say, for example, Bn minus 1 equal to An minus 1. Then you will get second order equation. Is that answer your question?
Okay. And wait,
Go.
and about the C1 and C2 on the slides,
Yes.
like what does it indicate?
Okay. So you remember the meaning of general solution and particular solution? Do you remember in our first order difference equation first. Okay, we'll come back here first, yeah, to the affine difference equation. Affine difference equation here. Do you remember this? Yeah. So
Yes.
yes, yes.
Yes. Yes.
Yeah. So this is called general solution, right? This is called general solution of affine, yeah. Okay. This is the general solution of this. This is the difference equation, right? And then this is the general solution. Okay. If you know the y0, you will get particular solution. Okay. If you know the y0, you will get the particular solution. If you don't, then this is the general solution. You remember? I hope you remember. So remember this, we have this equation, right? What is the solution of y10? Like that, yeah? So, and then you solve it, right? So last time we already solved this, yeah? Remember? So you use Excel to solve this problem, and then you get when is that happen, right? So the same thing, okay? So general solution is basically the equation that is general enough for that differential equation, okay, without recursion, okay? Without the recursion, you will get the general solution, okay? And then after that, if you know the actual value, okay, of the initial value, which is in here, A1 and A0, okay, then you get particular solution, okay? So this is the general solution, and this is the particular solution. What's the meaning? If I don't know A1 and A0, so I know the shape. Yeah? This is general solution, means the shape of the curve, yeah, with this exponential, right? If know the value of A1 and 0, then instead of that shape, this is an example of shape, yeah, I will draw here. For example, yeah, supposed to be the shape is something like this, right? But if you know the actual solution, okay, instead of that shape, I will put exactly this line. So that blue line here is the particular solution because I know the initial value. Okay, if I don't know the initial value, I know the shape. So I only know the gradient, right? So become the red curve. Do you understand the meaning of general solution and particular solution? If you use simulation, okay, if you enter into Excel, that is simulation, right? So that means you can only get the blue line. You cannot get all this red line. But using mathematics, okay, using algebra like this, you can get the general solution, meaning that you can get all the possible line of the general solution. That's the difference between mathematics and the simulation. Simulation is only one particular line. Okay? So, now, let's come back here. Okay? We have second order difference equation, right? This is the second order difference equation. Okay? And then, we call this quadratic equation as characteristic equation. Okay? Why? Because this characteristic equation is the one that we need to solve. Okay? To be able to solve this second order linear equation. Okay? So, but if you solve this quadratic equation, there are four possible type of solution. Okay? Okay, let's divide by 2 first. One is called distinct root. Second is called multiple root. What's that mean? distinct root mean the solution of this x1 is not equal to x2. Okay. Remember, when you do a quadratic equation, you can solve. Okay. You will get two solutions, right, in any quadratic equation. So x1 and x2. If the x1 is not equal to x2, that is called distinct root, yeah? Meaning the root are not the same. Okay. Or we can have double root, yeah, multiple root like this, meaning x1 is equal to x2. Okay. Now, we are more mature now, so we are no longer in high school. You learn quadratic equation can be solved only when the root is positive, right? The discriminant is positive, right? But now we can say that, look, if the discriminant is negative, that means complex number. Okay? So if you have complex number, okay, that means your solution will become oscillation later. Okay, so this is example, yeah, example. Okay, so can you find general and particular solution of this second order difference equation? Okay, so look, what you will do if you know this problem. So first you will do the characteristic equation, okay, right? And then you solve this quadratic equation, can you? So you will get x is 2 and x is minus 3. Oh, x1 and x2 is not the same. So they are distinct root, right? So remember the general solution, the one in yellow, this one, right? This is the general solution, right? So what you will get, C1 times R exponent K, C2 times S exponent K. What is R and S? The root. Okay, so that's what we will do. Okay, so we know the root is 2 and 3. So then you will have C1 times 2 exponent K and C2 minus 3 exponent K. So this is the general solution. Okay, is it clear? Right, and then how you will get the C1 and C2? Oh, remember we need to know the two numbers, which is the initial value, because we have second order, so you need to have two initial value, yeah, A0 and A1. So I know A0 is 7, A1 is minus 6. Okay, is given, right? So then we just input into the equation, we get C1 and C2. Okay, do you know this equation come from? Come from here. You see? So we know A1 and A0, we know R and S, so we can get C1 and C2. Clear, yeah? So, and then, now I know C1 and C2, what I will do? Input this C1 to the general solution. Input this C2 into the general solution. Then you will get, that is called particular solution. Okay? So the general solution still contain the parameter C1 and C2 to be determined by the initial condition. Okay, is it clear or not? Give me feedback. This is the foundation. After this, going up and going up. Go. You ask first.
This part is clear because we just kind of plug it in, right, to the previous one.
Yeah, just plug
One is
in
clear.
that formula.
It's simple, yeah.
Yeah, it's really simple, yeah. Livi, okay? Sure?
Yeah.
Yeah, okay. Let's go. Okay, this is your assignment letter. Okay. Okay. So Fibonacci, you know Fibonacci, right? Our grade will be in Fibonacci also, right? So this is A0, 1. This is A1, 1 again. And then 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. And so on. Okay? Oh, this is a sequence. Can we put this into dynamical system? Can we find the particular solution? Okay. So, we know, right? Dynamical system is f of n plus 2 equal to f n plus 1 plus fn, right? Easy? Yeah. And we know the initial value. What is the initial value? This one. A0 is 1, A1 is 1. Okay? So, and then how you will put this into characteristic equation? Here, this one become x squared. This is x, and then what is this? 1. Okay? So, and then what you will do? You will solve this characteristic quadratic equation here. So, the result is this 2 roots. This is distinct root. Hey, do you know what is this number? Do you know what is these two numbers? Okay, check. Golden golden section or golden number. Check in Google. Golden number. Is that correct? In Google, when you check golden number, oh, golden number Fibonacci. There. Okay, golden ratio, golden number. What is that value? Oh, there is a, I think there is a Wikipedia. Golden ratio. Can you see? I will share the screen. Golden ratio. Oh, golden ratio. Actually 2, that plus and minus actually. So that golden ratio, oh, plus and minus here. Can you see this? This is the golden ratio. Wow. Okay, this is what exactly we just get in the slide, right? That actually the root, okay, the root of the difference equation, yeah. Okay, so if you want to know more, so you can just read by yourself the Wikipedia, right? So come back here. Okay, this is the root, the distinct root of the dynamical system of Fibonacci sequence. Okay, and what happened is, because we know the distinct root, okay, then we know the general solution. Okay, so this is the general solution, which of course consists of C1 and C2, right? Then you calculate the C1 and C2 because you know the F1 and F0. Yeah? So if you input the initial condition, you get C1 and C2, and then you get the particular solution of the Fibonacci, which of course contain the golden ratio. They said the golden ratio is the most beautiful ratio, because many buildings, even the nature will have this kind of ratio. In fact, last week I just got the news. Even the election, the number of election, okay, the ratio is also passing the Golden ratio.
Mm.
Number of
But
participants.
the thing about the golden ratio is like, is it like, I mean, it's very weird that almost every aspect have it. So do you think it's like a coincidence, or is that like some?
Yeah, so that is true. So a lot of people thinking, is it coincidence or is it actually natural law, right? Like, look, in the nature, okay, there are a lot of natural law that actually uh, will create certain things, okay, that we try to discover that law. Okay. So the one that you learn in physics, right? For example, like force equal to mass times acceleration and so on, right? Those are natural law that we put it into science. Okay. The same thing with this mathematics of Fibonacci sequence. Okay. Uh, when they study about nature and then they discover that the nature actually have this kind of pattern, okay, and then even the pyramid, the pantheon, also using this ratio, right? So this is very interesting. Okay, and then even the nature of the number of leaf, for example, they also use the same ratio. So I think this is not coincident. Probably this is part of natural law that we are still learning to discover more and more about it. Okay, so yeah, nature is very amazing actually if we want to see the pattern. Okay. Right. Now, the same thing here. Oh, maybe you can solve this. Can you try? Practice, practice. I want you to practice at least one.
This one we just plug in, right?
Let us see.
Okay.
What you will do, create the characteristic equation. Yeah? So this one is x squared equal to 2 times x minus 5. Can you solve that? So it's just solving quadratic equation. I hope you still remember. But the things here is, I want you to say you use ABC formula, right? To solve this, right? So the one inside the square root is negative. Okay? So you remember square root of negative 1 is I. It's a complex number. Can you solve it?
So so first we use
Yeah. First, you need to put this into quadratic equation.
quadratic. Okay.
Okay.
The quadratic one is the minus b plus minus.
Yes.
Okay.
So minus b plus minus square root of what? 2, no, b square minus 4ac, right? Divided by,
Yes.
yes, divided by 2. Oh, I already forgot. That's probably 40 years ago. Yeah, during
Or
high
during
school.
middle school, I was so bad at math. Every
Oh.
exam, I just write this formula, try to plug it in.
Yeah, yeah, you don't need to memorize anyway. Uh, when you try to do it, you will eventually memorize by yourself.
Yeah.
Right. So, yeah, this is the solution that I got. Okay, is that the same as yours? Did you get it? So, what do you think, Livy? Did you make it? You get the root? Yes. Is it the same? I cannot hear you. Sorry.
Oh, yeah, I haven't finished
Okay,
calculating.
you do it first. You do it first. If you wait. My concern is sometimes some of the students did not learn complex number to high school. So this is the time to learn. Joy, did you make it?
Yeah, I'm currently working on it.
Okay, still working. Okay. So what ABC formula of quadratic equation, yeah? So that is, let me check in Google. ABC formula of quadratic equation. Okay. There. Okay. There. Okay. So the formula is just minus B, right? Share my screen. So minus B, okay, plus minus square root of B square minus AC. So the quadratic is this form. So you get the A and B and C. So in our problem here, the characteristic equation is A is
Mhm.
B is minus 2 and then C is 5. Okay. So in that case, you can put into the quadratic formula. Okay. So you get x1 and 2 is using this ABC formula. Yeah? Okay. Okay. The problem is only now the one inside the square root is now negative. Is that correct? So, but you know,
Yes.
negative 1, yeah, square root of negative 1 is equal to I. Okay, square root negative 1 is equal to I. Okay, so in that case you can solve. Okay, and you will get
Oh, so square root of -1 equals to I.
I. Yeah, I. Do you know complex number? Did you learn?
I did not know.
Okay,
Complex numbers.
complex number, yes. I think I make a tutorial on complex number long time ago. Let me check if I have it.
No, I did. Are we supposed to learn this in high school?
Oh, you did. Okay, so good. Complex.
I did not.
Oh, you did not.
We like
Okay.
I
Here.
did not. Like I think the teacher briefly mentioned, but I never really like got to
Okay,
use the
okay.
like
So I have a
explain complex number.
tutorial. Okay, I have a tutorial of complex number in my website in Grateful Edu. So you can check about it. Oops. Okay. So complex number tutorial. So what is complex number? So here, can you see this slide? So complex number, okay, is the generalization of both, yeah, real number and imaginary number. The I there is called imaginary number, okay, and real number consists of two, what is called rational and irrational. Yeah? You know pi, okay, 2 pi r, yeah, is the circumference of a circle, right? Or pi r square is the area of circle. Yeah? That is an example of irrational number. Yeah? The same thing with exponent e. Okay, the e there is an Euler number that is also irrational number. Yeah? So rational number consists of fraction and integer. Integer consists of negative, zero, and natural number, while the zero and natural number is called whole number. Okay, so complex number consists of two parts, which is real part and imaginary part. Okay, so if you want to know complex number in Excel, okay, you love Excel, right? So I will open Excel. I will open, I will share my screen. I have Excel here. So say I have 2,3. Okay, so this is called real and this is the imaginary. Yeah? Imaginary number, yeah? Real number and imaginary number. So if I put complex, okay, I will put real, comma, the I is the imaginary number. Yeah? There. I need to put I. Inung, yeah. So supposed to be I. Okay. Oh, why? Why it doesn't work?
Is it because you click C2 instead of C3?
Oh, oh really? Oh, sorry. C3, C3. That's why. Oh, okay. Okay. Then see? Oh, Excel can create a complex number. Okay. So so you can handle complex number in Excel. Okay. So no problem, right? So with that, imagine basically what you have is, oh, my tutorial is so bad. This is long time already. I did not update. Anyway, do I have it? Okay, so this is basically talking about different algebra of complex number, and from there you can create a complex geometry. Okay, that you can also create. This is I created in Excel, so you can do a fractal and different shape, okay, of fractal based on complex number. Okay. So this is basically based on dynamical system. Anyway, let's go back to our topic. Okay, so what we have is a complex number here, right? And why complex number is important? Because of what is called Euler formula. Okay. So you go to Google, okay, and Google it Euler formula, okay, in Wikipedia. Leonhard Euler is a mathematician about 1700 something, okay, and he discovered, okay, the formula which is very interesting. Why? Because this is exponent of a complex number I, x, is actually equal to geometry. trigonometric. Okay, of cos x plus I of sine x. Okay. So what does it mean? It means when you see a complex number like this, okay, the behavior will be oscillation, okay, up and down, right? So you can check in Wikipedia by yourself, right? So this here you see this complex number, yeah, is basically the same as trigonometrics and the same as exponent of the complex number. This is amazing formula that discovered 300 years ago. Yeah, about. So basically what I want to emphasize here is, look, if you have second order equation or whatever order equation and your solution is complex number, okay, something like this with I, right, that means the behavior will oscillate. Okay, so now if you want to put in, so you just put, this is the general solution because you get the distinct root. Okay, you just put it into the formula a while ago, right? With that, if you know that C1 and C2, you can directly compute. Yeah, you can directly compute. Okay, if you know the A0 and A1, you can compute C1 and C2, and then you can get the particular solution. And if you look at the result, okay, this is a sequence with this positive and then negative and then positive again and then negative again. So oscillate. Okay, clear or not? Okay, it's just plug into the formula. Okay. Now, second part of it, I mentioned earlier here. Okay, we are talking about, look, if I have this equation, right, system equation of second order, okay, have four possible type of solution. We already discussed about distinct root, okay, whether they are real number or complex, right? Now let's discuss about multiple root. Yeah? The complex and real number is the same. Okay, the difference is this is always oscillate only. Yeah, but what happens if you have multiple root? Okay, so I will show you. If you have a multiple root, right? Remember C1. This is the formula of C1, right? If you have multiple root, R is equal to S, isn't it? Oops. What happened? You cannot use this. Because R equal to S, okay, then something divided by 0, right? So in that case, the previous formula you cannot use. Okay? So, okay, you said, I cannot use, so what can I do? Okay, here it is. Okay? If you have second order with multiple root, okay, this is what happened. Okay, usually the form is like this: 2r, okay, of an here minus r squared. Why? Because with this you will get exactly this one, right? So this is the equation, characteristic equation, and this is the one that caused the multiple root. So r here is the root, right? So you have double root, okay, x1 equal to x2 equal to r. In that case, be careful, yeah, the general solution is not like a while ago, but this one, the one in yellow. Can you distinguish? the earlier, okay, the one in yellow also, you have R and S because, okay, you have distinct root. R is not equal to S. Okay, this is the solution. Okay, now if you have exactly the same solution, R equal to S, you cannot use that formula. You need to use this formula. Okay, after that, if you want to get C1 and C2, you just plug into this formula. Okay, tell me what you can. Easy or not? I give you the formula, you just plug in. Divi, give me feedback. Divi, are you still there? Joy?
Yeah, I think it is lagging.
Lagging.
Lagging, yeah. She's not moving.
Oh, okay. So can you get it or not? Multiple root, distinct root. Can you distinguish? Do you understand the meaning of multiple root and distinct root?
I think so, but I'm not quite sure.
Okay.
Mm.
Okay. What do you understand so that I can get your?
Oh,
Tell me what you understand so that I can get your feedback.
uh, if it has a distinct root,
Mm-hmm.
it means that the solutions
Mm-hmm.
are not equal to each other.
So, okay, let me summarize, okay? So, can you see my whiteboard?
Yes.
Okay, so if you have a distinct root, okay, so you have this equation, right? A, I will put here, A n plus 2, okay, equal to, so small a of n plus 1, okay, plus b of an. Okay, this is your uh, equation. Okay. Now, if you have distinct root, yeah, distinct root, distinct root, that means, okay, x1 is not the same as x2. Okay, so that happened because your characteristic equation of this is x squared, okay, equal to a times x plus b. Okay, so you have x1 and x2 as your root, right?
Yes.
Root equal to x1 and x2. Okay. So if you have distinct root, okay, so what is the solution? If you have distinct root, your solution is, I will put here, AK equal to C1, okay, multiply by R, which is X1, okay, exponent of K plus C2 multiply by S, exponent of K. R is X1, okay, S is X2. So I will put it here. Okay, so R equal, oh, yeah, R equal to X1, right? And then S equal to X2. This is the summary. Okay. So now if you have multiple root, okay, if you have multiple root, so let me put again here. So if you have multiple root, right? That means x1 equal to x2 equal to r. Okay, so in that case, your solution is, okay, so in that case, your solution is AK, okay, equal to C1 plus C2 times K, okay, times R exponent K. Okay, so these are the summary. Is this clear? So,
Okay, so distinct root x1 is not equal to x2.
so you have,
Well, multiple root x1 equal to x2 will, okay.
okay, so this is like the summary. Okay, with this you can solve any second order problem, right? So complex or not complex is the same, yeah. It's just put into I. Okay, so most important part is distinct root or multiple root. Okay, so is there any question? Okay, let's start with practice then. Okay, so I want you to practice. Okay, this is just the derivation why it comes. So let's practice this one. Okay, so you can solve this problem using first order or second order. Okay, let's do it both. Okay, so say your gas consumption is 20 kilometer per liter, and then you just fill up the tank with 15 liter. Okay, so the model the amount of gas left after driving n kilometer as dynamical system. Yeah? So in that case, so you will put AN equal to the amount of gas left after driving n kilometer. Say, so you use, for example, a 0.05 liter gas in driving 1 kilometer. So you will put this equation, right? So this is what? This is affine, yeah? Affine difference equation. Yeah? So the particular solution become this equation here. Now, if you want to put it into second order, yeah, so you put it this way. So if G is the amount of gas used per kilometer, right, then we can define A plus 1 equal to AN minus G. Okay. Oh, what is this? This is the general solution is this equation, right? Wait, I will put it this way. So this is the general solution of this, again, affine difference equation. Okay. So now if you want to put it into second order, okay, then you can write it this way. You see, an plus 2 minus an plus 1 equal to an plus 1 minus an. What does that mean? Meaning the gas that you use in 1 kilometer, yeah, from an plus 1 to an plus 2, yeah, is exactly the same as the gas used to any other kilometer, right? From an to n plus 1. Yeah? So this is the difference equal to the difference. Okay. With that, we can solve, right? So if you put it together, this is an plus 1. You put it on the right side, become 2, right? This is negative, become positive, so become 2. Yeah? 2an plus 1, so minus an. Oh, you see this? This is what? The solution is double root. Yeah? This is the solution is double root, which r equal to 1. Yeah? With that case, you get exactly the same particular solution. So, any question? Is this too much or?
So far, it's clear.
Oh, so what is clear? How about Liffy?
Yeah, I think it's okay.
It's okay, yeah. You just put in two formula. Yeah? This is the example a while ago, right? Okay. Okay. So this is the general. Now this is the topic, but the same within the same scope. Yeah. Suppose you have a second order equation like this. Yeah? An plus 2. Yeah. A while ago, as until here only, right? Until a times an plus 1, b plus an, right? But now we add, okay? We add with gn. What is gn? This gn is now become polynomial, very complex. Okay. So, wow, if I have this kind of equation, can I solve it? Yes, you can still solve it. Yeah? How to solve it? Still the same. Yeah? So, the gn does not really matter here. You still need to get the characteristic equation of the homogeneous first. Yeah? So, when you have gn in here now become non-homogeneous, right? So, then you can solve this. Yeah? So, the same root is x equal r and x equal s, so x1, x2. And suppose this is your polynomial function, which is Pn times n exponent m, and so on, yeah, until p0. Then the solution, now depending on the value of r and s. Yeah? So whether it is plus equal to 1 or not. Okay? So these are the solution. So I just write here the general solution, just in case you face this problem, you know how to solve. Okay, and the particular solution of all of those depends on another constant, yeah, which is qm until q0. Okay, that can be found by substituting the dynamical system. Yeah. So, and then you will solve m plus 1 equation for m plus 1 unknown. Okay, let me give example so that you will understand what I'm talking here. Okay, so this is the example. You see, I have, this is the, what is this? Second order, right? This is the highest, right? This is the lowest. So, this is second order, linear, okay, non-homogeneous, because now I have 7 minus 2n. So this is the polynomial a while ago. Okay. Simple polynomial. Okay, and of course, because this is a second order, I need 2 initial values. Yeah? Okay, how to solve this problem? Again, you create the characteristic equation. How do you can create the characteristic equation? You check earlier. Yeah? Here, you see, this is what? X squared equal 4 times x minus 4 times 1. Don't care about the polynomial. Okay, don't care about the polynomial. So here you get the characteristic equation. Oh, it's double root. Okay, so you get the double root. Okay, and you know the general solution is of double root is this one, right? And then what is this? This is the q a while ago. Yeah. So we have a qm minus 1, q1, q0. This is basically the solution of this one. Yeah. See, yeah? This is the solution of the linear homogeneous, yeah? Second order linear equation. And this is the q part, which is the part of the polynomial that we need to solve. Can you see it? Okay, again, this is the solution for the homogeneous part, and this is the part which is for the polynomial. Okay, of course, the polynomial is based on p. Okay, so the solution is based on q. So q is just number. Okay, so the same thing. This is the example here. So this is the polynomial, right? So this is p1 and p0 and p1, right? And then the q we don't know, so we just put a and pk, the same shape as the polynomial. Okay, so c1 and c2, how do you get? That depends on the initial value. Yeah? And then a and b here, how do you get? Depends on the function, yeah? Depend on the gn. Okay, so example, okay, this is suppose, okay, because if I don't put this become very long, right? So I just put dot in here. Okay, remember this part here, I put it as dot. Okay, yeah, c1 plus c2k 2 exponent k here. Yeah, I will put it as dot so that I will shorten the formula. Okay, so I put it as dot, so we know that an equal to dot plus a plus bn. Okay, and again an plus 1, what is that? Same dot a plus bn plus 1. Yeah? An plus 2 equal to dot, the same dot a plus bn plus 2, and so on. Okay, so in itself this one is already another difference equation, right? So if you put it in, okay, you will get this value. Yeah? And if you solve algebraically, you will get b and a. Yay! Okay, so you solve the a and b by inputting this value. Is it clear or not? Try to grasp it. Give me feedback. If something, you still doubt something, you tell me. I can try to explain it another way. Livy, Joy.
I suppose it's okay.
Really? So you understand this dot is just shorten of this one, yeah?
Yes.
Okay, so that I will be able to get A and B here. Okay. Anyway, this does not change, right? Because this is already A and not depends on N, right? So this is like a constant, right? So I can just put that. Okay. So when you substitute this, you get A and B. Oh, okay. So then I already know A and B, so I put it here. So I get the general solution, remember? Okay, to get the particular solution, again you solve C1 and C2, yeah, using the earlier.
Mm.
Okay, then you get this particular solution. Yay. Okay,
I have a question.
cool.
How do you apply, like, when do you apply the non-homogeneous equation in real life? Like,
In real life,
when
you will solve a model, right? Remember,
mm,
you to create your own model. Okay, so at certain particular time, you will see the model that have some force, external force. This one, the Gn is here is represent the external force that you input into the system. This is your
mm,
that will try to control your system. Okay, example of real life application of this. So many actually, yeah. For example, you have a rocket. Okay, you're a missile. Okay, say one enemy is creating a missile like this, and then you have a rocket to uh, hit that missile. Okay, so that means you remember one particular missile is already moving, right? And then you have another rocket to hit that missile. So that means internally you need to create that force here inside the rocket to hit that. This is just example. Many other example, yeah. Do you see the behavior of a motorcycle that actually can autonomously move by itself, that never fall down?
mm-hmm.
Did you see in the internet over that?
What there's
Yeah, for example, bike or motorcycle that actually can move, right? And then it will never fall automatically. That means there is a force that apply to that motorcycle or that bike so that it will never fall. There is something that controlling.
mm,
So you apply certain force to that system. This is the system. This is the force. Okay, maybe I will show you the next slide so that you can, I hope, I hope you can understand better. Where is the next slide? The next slide is about the uh, state space linear system. This is already finished. Oh, okay. Okay. The next slide is the transformation of the first order. Okay. So I go to the next slide with this state space linear system. Can you go to Lentera? Yeah. And go to the next slide. Can you download it? State space representation.
yes.
Yes, Livy, can you get?
Yes,
Oh
sir.
wait. Okay, it's the same. It's just a
Yeah, I
different
say
data.
I
Yeah.
just add this one. Okay.
Okay.
Okay. Anyway, so okay, in this slide, I'm talking about okay. The last slide of the first, second order is also the same thing as this one. Okay, I'm just making a better way to explain. So in here, basically what you will do is to represent any order. Okay, of course, second order, third order, uh, fourth order, fifth order is the same. Okay, so any order into matrix form. When you can solve it using matrix, so you can use the linear algebra. So basically, this is a system way to to do discrete dynamical system. Okay. Maybe tomorrow we can discuss about Markov chain in OR, which is exactly the same as this one. Okay, so okay, this is the connection between matrix and linear difference equation of n order. Okay, let us see here. Maybe my writing is rather complex, so let me make it smaller so that not that complex. I need to put it not that way. Until bn minus. Okay, maybe this is better. Can you see it? So y, okay, depends on u and depends on the previous y. Can you see that? This is called n order. Okay. So n order of difference equation. So the u here represent the force. Okay. And this is the system that you have. Okay. So B0, B1 up to Bm ada constant. Okay. A1, A2 until An also constant. So what is this? You have n order linear difference equation. Okay. Now you want to put it into matrix form. So important here is to understand the concept of state. Okay. So a discrete system is basically a mathematical abstraction, okay, that utilize three types of variables. Okay. So what are they? First is called the input, U. This is the force, the external force that will influence the system. Okay. And then Y, here is the output variable. Okay. Something that you can observe from the system. So this is the output. Okay. And you have the input U. Inside the system, okay, we have what is called state. Okay. Can you get it? We have three types of variables. Okay, I repeat, yeah. We have input, the name is U. So what is the U? U is a vector of U1, U2 until UM. Okay. And then you have output Y. Okay. Y1, Y2 until YP. Okay. And then inside the system you have internal state. Okay. This is Y, X1, X2 until Xn. See, even the length of the vector is not the same. Yeah? M, N, and P. Okay. Now, what is state? State of the physical object is any property of the object which relate the input to the output. Okay, so that the knowledge of the input time function and the state at time t will completely determine the unique output for t, for the same time step. Okay, so basically state is just the internal variable within the system. Is that clear? Okay, so this discrete dynamical system here and or the linear difference equation here, you can put this into matrix equation something like this. Okay, xk plus 1 equal to A is a matrix, okay, times xk, so this is the first order equation, right? And then times B, another matrix here, times U. What is AK? AK is the system matrix that transform n by n, yeah? So this will transform the x into another x, right? How about B? B is the distribution matrix of the input U to the system, yeah? So in that case, the number of input U is M, right? So in that case, B size must be N times M, okay? So with that, this is called state equation. Okay, look at this. Important here is the size. Okay, the state vector, okay, have size of n comma 1. That means n rows. Yeah? The input vector, the force, external force to the system, have m rows. Okay, so the system matrix, which is internal of the state variable, if n by n, same as this one. Okay, while the B in here is to distribute the input to the system, that means n by n. Okay. Next, look at this equation here. A depends on K, that depends on time. B depends on time, okay? To simplify, let's assume that AK is equal to A and BK is equal to B. That means not depends on time. So, okay? So that means time invariant. Okay, we assume that. Okay? Now, with that, we can start to separate, okay, the input, the output, and the state vector. Yeah? This is the input, this is the output, this is the state vector. Yeah? The input is U, the output is yeah? Y, okay, and then X is the internal variable inside the system. Okay? Okay. So with that, this is the general state space representation. Okay, so this is the thing that you need to memorize. Any system, yeah, as long as they are linear, you can represent it as this equation. Okay, I will test you. What is U? Levi, what is U in here? What is U, what is X, and what is Y?
The input of the input of A and the input of B.
Yeah, the U here represents the force, okay? The force that you input into the system. The one that a while ago is the Gn. This U here is basically the same as your Gn a while ago in the second order. In the second order a while ago, right, we have Gn. Can I show it back? When you have non-homogeneous like this, okay, and then Joy was asking when I should use this, okay, right? So when are you going to have Gn in here? This is the force. Okay? The Gn can be in this form, polynomial, right? So this is the U. Now, in the next slide, this is the U. Okay, the An here, okay, This can be X, can be Y. I hope this is clear. Is it? So, okay. Now I make it into two equations. Okay. One is the X and the other one is Y. Okay. Right? Can you see it here? This is the force that influence the state variable, which is internal within the system. Okay. And then this is something that you don't observe. You don't see it. From outside, you don't see. Okay. So this is the force that you put in, and then internally, this is the working condition inside that system. Okay. And then what is the one that you see is actually Y here. This is the output that you see. For example, if your system is about money, stock market, right? What you see is only the input. For example, the event. Oh, there is the bank doing easing, for example, or there is a war. Okay, so this is the input. Okay, so the output is the fluctuation of the stock market, the price. Okay, so the one that you model is this one, the whole thing. So what is that? Inside that system of the stock market, of the economy, there is state variable that you don't know. The one that you know is only U and Y. Do you get it? The idea of state space representation. Okay, so yeah, the state factor is the internal variable inside the system. You don't see that, but there is. Yeah. The output is the one that you can observe. Again, the input is the one that you force into the system. So I draw a while ago this way. Oh, this one first. I hope you can understand this, because if you don't understand this, it's very difficult to go further. Oh, what do you understand, Livy, Joy, based on this? Tell me what you understand in your own word.
Uh, it's basically a system. So when you put something in input, then you will
You get the output.
calculate, you will
Right.
get the output, and then in between there will be like the X, which is like the internal
Yeah.
things from the system, which
There
will
is an
affect the
internal.
output.
It will affect the output. Correct. Very good. But the internal things you don't see. Okay.
Mm-hmm.
There is. That is the basic concept in here, is to have a state, okay, which is inside the system. Livy, what do you understand, Livy?
It is like general like a system when you have like the input and then you do the like the internal states, which is like the process. You will come out with the output, which is the one that we have already
Yes.
processed in the internal system.
Okay, okay. So remember here, the output is the observable. Okay. The one that you observe is the output, yeah? Not the input, not the state variable. Okay, so that's why the way you model is something like this. Here. Okay, so this is the input to the state, right? And then again, the input to the state, and this is the output. Okay, and all you need to do is to remember the size. Okay, otherwise it will not work. Okay, so of course, state representation of difference equation is not unique. There are many ways. Okay, I don't discuss other ways. So there are many ways, but you need to use Z transform, Laplace transform, and so on. I don't want to do. I don't want to touch that. So let's do the simplest way, which is called natural selection of variables. Okay. So how do you select the variable? So let's do it this way. Suppose this is your difference equation. Okay. Suppose this is your difference equation. So yk plus a1 is a constant, right? Yk minus 1 plus a2, yk minus 2, and so on until an of yk minus n equal to the force. Okay, suppose the force is just a constant times uk. The force is depend on the time. Okay, so how do you select state variable? Okay. Right? How do you create the state variable? Is this. Remember, this is your given. Okay, the y and u is the given. Now you want to create the x. Okay, so you select this way. So x1 equal to, remember the highest is yk, so you put yk minus 1. Right? And then x2 is the second one. Okay? Yk minus 2. X3 is yk minus 3, and so on. Yeah. If you have a yk minus n, then you have xn. Okay. This is, you will select this way. This is the most natural way to select. So what happened? Because x2 is equal yk minus 2, but that is exactly the same as x1 k minus 1, isn't it? Right? Remember, yk minus 2 and this is yk minus 1. So, but yk minus 1 is equal to x1. So I put it here, right? So this is the same as x1 k minus 1, right? The same thing here. This is the same as x2 k minus 2, right? And so on. So finally you will get xn k minus n. Okay. So you can start to relate one x and the other x of different order. Okay. Next, what you will do, put back into this difference equation. So once you know the x, put back into here, and then you will get the matrix. Okay, so when you put back into difference equation, you will get this kind of matrix. Yeah? So x, this is the matrix A. This is the form, you see. Yeah, the form is, you can memorize, or you can just look at the format here. Okay, so this is A1. Okay, this is A1, right? And then A2 minus, again, minus A3 and so on until minus AN, yeah, minus AN here. And then this is like identity matrix. Okay, this part is like identity matrix. And then the last part is just factor of 0. Okay, so multiply by, this is xk plus 1, this is xk. Yeah. Plus B 0. Of course, B0 is what? B0 and 0, 0, 0 multiplied by UK, right? And then, what is the second equation? The second equation is y, okay, multiply of a, or c, this is the c, okay, times x plus b d times u, right? So the c is just a vector. Yeah? Instead of matrix, in this case, you just make it into vector. And then the d is just a scalar, p0. Okay or not? Let's take example. Let's practice. Okay. Using general formula, it seems very overwhelming, so let's make it simple. Okay, so you have this equation, yk plus 2yk minus 1 plus 3yk minus 2 equal to uk. Okay, let's put this into matrix. Okay, let's put this into matrix. So, what you will do? So, this is our difference equation, right? So, remember what we will do? We select, yeah, x1 equal to yk minus 1, x2 equal to yk minus 2. Yeah? But if x2 is yk minus 2, that is exactly the same as this one, x1 k minus 1, isn't it? Right? You just put minus 1 in here, it's the same as this one minus 1, this one is yk minus 2, right? Correct? So, now we put back, okay, we put back this selection that we put as x1, x2 into this difference equation. Eh? So remember this one, yk, right? And then what is this? Yk minus 1. Oh, yk minus 1 is x1, right? Yeah. Yk minus 2 is x2, right? So, okay, so if you know that x1 equal to yk minus 1, okay, if I plus 1 in here, what we will get? Okay, x1 is x1k equal yk minus 1. So if x1k plus 1 is equal to yk, right? Do you get it or not? Should we do it in the whiteboard? Okay, so I will delete this whiteboard. Okay, so we have, okay, oops, thanks. So x1k equal to yk minus 1. My question to you, what happens if I do x1 of k minus 1? Of course, that is equal to yk minus 2. Is that correct or not? Because this is minus 1, so I will put it into red. Oh, cannot do like that. Okay, anyway. So, this part alone, yeah, this is minus 1, so this one is minus 1, so minus 2, right? Correct? How about if they like this? x1 of k plus 1 equal to what? So, y of, this is k, yeah, now this one become k minus 1. So, if I plus 1 in here, so that means k minus 1 plus 1, so equal to k itself. Yeah? Right? Minus 1 plus 1 is 0, right? So k plus 0 is yk itself. Is that okay? So with this, yes, okay. Give me feedback if you want to. or question?
Actually, I'm a bit confused with the previous chapter. Is
Okay,
it the
which
same?
one? Okay, which one? Which one?
This,
Is this the one? Leafy, is it the one that you confused?
the one with the previous chapter,
Previous one. Okay, previous chapter.
like the previous before the before the state space.
Oh, the second order, you mean?
Yeah.
Okay, okay. So, okay, let us see. Second order. Is this the one?
Uh, yeah. Isn't it the same with the state
Yeah, it's the
space?
same. It's the same. Okay,
Ah, okay.
it's the same. Now I just want to put this into matrix.
Oh, okay, okay, okay.
Okay, this is exactly the same. Okay, the difference is now I want to put this into matrix. Okay, so if I put this into matrix, I don't need to calculate this characteristic equation here. So I can put into computer, right? Computer can solve it for me. That's the issue. I put it into matrix because I want computer to solve it for me. Okay. Otherwise, I need to solve this root and so on, right? So manually, I can solve this. Okay. But if I want computer to solve it, I need to put it into matrix.
Mm,
Okay. Because why? Because now I can solve any order, not just second order. I can put third order, fourth order, and so on. Okay.
okay.
Okay. So that's the motivation. So I just use different notation here. The one that I put A here, now I put it in the next slide become Y. So this is the same as Y n plus 2 equal to A. Yeah. So in the next slide is exactly the same, right? But I put it different name. Yeah.
Okay.
Okay.
So the only difference is like the process. It is the second derivative. The second order we use the characteristic equation, but the state space we use the matrix.
Yeah, if you want to put it into matrix, you need to create state space. So you need X, which is the state space, to connect between the input and the output. Okay, so here, okay, in the next slide, I will put it as this one. Y, okay, K plus 2, right, equal to A, Y, K plus 1, right,
Yeah, yeah.
B of YK, right, yeah, plus Gn, yeah, plus GK. G is a function. Right? So exactly the same, or in that case, I put it U, right? Sorry, eraser. So this is like U. Okay, so I will put it as UK. Yeah. So in the next slide, I will put exactly the same equation here. I just change the notation. Yeah. Instead of A, I change it into Y. Instead of GN, okay, I put it into UK. Is that clear now? Sorry if the notation confusing because different meaning. Is, is this still confuse you, Levi, or you tell me?
No, no, it's okay. I get the concept now.
Okay, you get the context, yeah? So now
Yeah.
put this equation, okay, here into matrix form. Okay, to make into matrix form, okay, if you look at this last part of this equation, it's the same thing, right? I have this equation, okay. What I'm doing is I create a new variable b here, equal to ban, yeah? And then bn equal to an plus 1, yeah? Which is the same as bn plus 1. And then I put it back here, okay? And then I will create a new dynamical system here, okay? So, and then that new dynamical system will become a matrix like this. Okay, so that is how we solve this, yeah, equation, yeah. So this is what I'm put as x1 and x2. Is it clear on?
Yes.
It's the same as x1 and x2. Okay, so okay, later you will do this assignment, yeah. Fibonacci, put it into matrix form, yeah. Okay, you know, right? Fibonacci is k plus 2, yeah, equal to f k plus 1, yeah, plus fk, yeah. So now put this into matrix form, yeah, like this. Okay, shall we go here, come back? So one way, okay, there are many ways to do the point is there are many ways to solve this problem, okay. One way is to use this this is called natural state variable, okay. If you have this form, okay, the highest is yk, then you put a little bit lower than that, higher, okay. So k is equal to yk minus 1, x2k equal to y2 minus k, and so on. Okay, so this is what you will substitute. Okay, when you know, if you substitute this is what you will use, right? Then you know that x1k plus 1, okay, equal to yk, x2k plus 1 equal to yk plus 1, which is equal to x1. Okay, right? So then you can put this back into the difference equation to make this matrix. Okay, so here, right?
Sir, are you writing on the whiteboard?
Oh, sorry. I did not put in the whiteboard. In the point. Sorry. Okay. Can you see it?
Yes, the one with your annotations, right?
Yes, with my annotation. Yeah.
Yes. Okay. Yeah.
Okay, sorry. So this is your, okay, let me come back. Okay. So this is your, suppose this is example of your difference equation. Okay. This is your difference equation, right? And then my suggestion is to use this as your natural state variable. Okay. How do you do that? Oh, easy. Look at this. This is the highest, right? So you just use 1 before the highest. Okay. So x1 equal to yk minus 1. Okay. Always? Yes, always. Okay. You put it into this form, okay, and then the highest is yk, right? And then x1 is always yk minus 1. x2 is always yk minus 2. Always. Okay. With that, you can start to play algebra. Yeah. So you know that if I put k plus 1, if I minus 1, so you will get all the other variables. Okay. So let us put here, if you look at this, yeah, I already said, yeah, x2 equal to x1 k minus 1, yeah. x1 k plus 1 equal to yk, x2 k plus 1 equal to yk minus 1 equal to x1. So what you will do is to arrange, okay, to arrange this. Okay, so how to arrange? You arrange so that the form is something like this. Okay, so here is you arrange. Okay, look at this slide and then look at the next slide here. Okay, look at this, how I arrange. This is x1, okay, k plus 1, and then this is what? This is the matrix of A times X. And then this is the B times U. Can you see that now? Okay, then you can just put into the matrix. Yeah? This is 2 minus 3, 1, 0, right? Okay. So the B is 1 and 0. The first equation you get 1. The second equation you don't, so that means 0. Right? How about the Cx? Again, you put it, this is the difference equation, right? So that means equal to this. Remember this 2yk minus 1, we already have it earlier. Yeah, here, can you see this? Right? So that means we can put it back into the form of C. Yeah? Into the form of C. Cx plus du. So I can get that. Oops. Okay. So if I know this is 2x1 minus 3x2, so that means x1 and x2 here. So 2 and minus 3, right? U is by itself. So I just put U here. So this is the form of yk equal to c times x. What is c in here? 2 minus 3. Yeah? D is 1. Is this clear or not? So once you can put any difference equation into this form, okay, state equation and observation equation, then you can solve it, yeah, using computer. Yeah. So look, the representation is not unique. Okay? It's up to you to decide. So this is another example, alternative way. For example, the first one I do exactly the same. Okay, in here, x2 is different. Yeah? In here, x2 is I'm using, this is the equation, right? So this is my x2. Yeah? You look at this equation, you compare it with this form, you see this is my x2. So with that, you get x1 k plus 1 equal to yk, right? From here. Okay. So that is equal to x2 times u. Okay. And then if you put plus 1 in here, what will happen? You will get here become 3 yk minus 1 plus 2 of yk. So that is, you put it in back into x1 and x2 and u, and then you will get this kind of form again. And of course, the result is not the same. Yeah? You see, the result is not the same. Can you see that? Yeah. The same thing with this. The result, because this is not the same, so the y equals c x plus du is also different. Okay. But if you run, it will get exactly the same. If you run it, it will get the same result. Okay. So matrix representation is not unique. Okay. As long as you put them together, you will get exactly the same result. Okay, so this one next meeting, we can continue this. So up to here, is there any question?
No, sir.
Okay,
Yeah, so far I get the concept.
okay.
So
You need to practice, huh?
yeah,
Because without practice, I don't think you will understand fully. Okay.
yeah.
And if you have any question, you can even WhatsApp me.
Okay.
We already start LCA or not?
No,
Okay.
last week is a holiday.
Okay, so see you then.
Okay, thank you, sir. See you.
See you tomorrow.